This is Precalculus Workshop Day 3. Today, what we will discuss is, what we're going to discuss first is actually where your textbook picks up, okay? It's arithmetic and geometric sequences. All right? So I'll write the two. It's called arithmetic. Okay, y'all, I want to put an E there, but you know, arithmetic and geometric sequences. All right? The difference, they're all lists of numbers. But with arithmetic, there's a common difference. We've really looked at these a lot because with an arithmetic sequence, they're all linear. So it's going to eventually look like a linear equation. But it's something like 2, 4, 6, 8, 10. What have I added each time?
2.
So I'm going to call my common difference lowercase d, all right? My common difference is 2. All right, this is my output. The actual numbers are the output, are the y values when we graph them, okay? But if we start with 2, if 2 is the very first number in the sequence, then we're going to label it. And different textbooks label them differently. I'm going to use the one that our textbook labels it. It's U sub 1 is the first one. Some label it A, A sub 1. The ACT uses A. All right, so this, all I'm saying is the first term in the sequence is 2. Make sense? That's what that means. The first term in the sequence is 2, is equal to 2. Then 4 would be U sub 2. Such that the second term in the sequence is 4. Right? All right, so it's new terminology. And we're going to get to the place where I could solve for any value in the sequence. Like I could solve for the 30th value in the sequence. So that's what we use sub n. So n is now going to be like our x value when we graph it. Makes sense so far? The terminology makes sense? All right. So if I want to get to U sub 3, you already know what U sub 3 is, don't you? But if I want to get to U sub 3, I really could take U sub 2, the previous term, and what would I have to do to it?
Plus 2.
Plus the
Difference,
right? I could just add the difference.
Baby did.
Make sense? Or I could, focus right here. This is all new terminology, and I just don't want it to be all new our first day. All right. Or I could say, to get to any term, U sub n, I could use the previous term, U sub n minus 1, and add the difference. That's the same thing as writing U sub 3 equals U sub 3 minus 1, which is 2. You see that? Plus the difference. But this is using variables. So u sub n minus 1 is the previous term in the sequence. Make sense? U sub n minus 1 is the previous term in the sequence. This actually has a name. It's the recursive form of the arithmetic sequence. The value of the recursive form is that if I know the previous term, I can know the next one. All right, we're going to learn another form in class which actually looks like the slope-intercept form. All right, so I could get, that's u sub 2, that's u sub 3, that's u sub 4, that's u sub 5. So I could figure out what u sub 6 is by taking u sub 5. So I can figure out u sub 6 by taking u sub 5 and adding the difference. But right now, if I wanted u sub 30, I really don't want to have to go through 29 sequences of this, right? So what I could do, let's go ahead and figure out u sub 10. All right, so that's 6, 7, 8, 9. All right, so it's 10, 12, 14, 16, 18. We know it's 20. Right, I just added. But could I get to say from u sub 2 to u sub 10 without having to go through the recursive form? I can, and it's called the explicit form. Okay, so u sub n stands for the one that I want to solve for. U sub n minus 1 stands for what? The one right before it, yes. And u sub 1 stands the very first term, all right? So we could go 2 to 10, but that's a little more complex. We're going to go from 1 to 10. Let's go from 1 to 10, all right? Because the explicit form requires us to know the first term in a sequence, all right? So the explicit form is I can solve for any term by having the first term. I have to know the first term. Now, could I just say how many times I add the common difference to it? I could. Let's guess. Let's count it. How many times did I add the difference? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times, right? So I have to take the difference, multiply it by 9, and add it to the first one. Are you following me? To get the 10th one. You got it? Does that make sense? If I wanted u sub 12, how many times would I have to multiply the difference by? 11. That's if I wanted u sub 20, how many times would I have to multiply the difference by? 19. That's the pattern. It's always one less than the term that I want. Does that make sense? So I'm multiplying the difference by one less than the term that I want. Got it? You got it? You following that? Okay. So I'm going to write that equation in those words that I just said. I take the first one and I add to it. I add to it the difference times one less than what I'm asking. You got it? Got it? So, if I am looking for u sub 10, then I'm going to take the first term, I'm going to add to it the difference times what? Which is 10 minus 1. Got it? Got it? So if I wanted u sub 25, what am I going to do? Take the first term and add the difference times 25 minus 1. Got it? Which is 24. Okay, so let's do this actually for u sub 10. We said it's 20. All right, so u sub 10 will be the first term, which is 2, plus the common difference, which is 2, times 10 minus 1, which we know is 9. 2 times 9 is, plus 2 is, we got it. Got it? Okay. Now I just want to look at this and let's give, we're going to write, okay, let me rewrite this. All right, so u sub n equals u sub 1 plus the difference times n minus 1. All right, we know u sub 1 is 2. We know the common difference is 2. All right, let's multiply that out. All right, so u sub n equals 2 plus, let's distribute, 2n minus 2. I could simplify this to say u sub n equals 2n. And I could say plus 0. And does that look like y equals mx plus b? It does. Okay, now we can plot these on our calculator. Okay, we're going to plot a small group of them. We'll just go 2 to 10. Okay, my y value, everybody look, my y values are going to be 2, 4, 6, 8, 10. My x values are going to be 1, 2, 3, 4, 5. Yes, no, I'm so excited.
So cool.
Okay,
We should make a song.
so turn your calculators on. Look, I've already graphed some of these. Okay. Do you see the stat button? S-T-A-T. Look,
Yes.
it's right here. Got it? Stat. Right below delete. Everybody there? Micah, do you have your calculator?
Yes.
Okay. Are you with me? Turn it on. Hit stat. Okay. We are going to edit list. We're going to edit. So just hit enter. And it'll bring you to lists. Let me see everybody's calculator.
Mine's got numbers all over it.
Yes, because you have siblings. Nothing. Do you have? Mine has numbers too. Okay. So if you'll watch, follow me, Leah. If you have something in your list, you toggle up and it should highlight list 1. Got it? And then you hit clear and then go back down and it clears your list. I'm going to go clear my list 2. Go up, highlight list 2, hit clear, go back down, and it clears it out. Okay, so now, does everybody have list 1 as your first column? We're going to make list 1. Are you with us? You're cleared?
Yeah.
Okay, I just want to make sure you were able to clear it, okay?
Yeah.
All right, we're going to make list 1 our x values. So we're going to hit 1 and enter.
Where do I put 1?
Just, if you are at the top of list 1, enter 1, enter.
Press 1.
Press 1, enter. Then 2, enter. 3, enter. 4, enter. 5, enter. Everybody have 1 through 5 in list 1?
No, press 1. How far do I go down?
Just to 5. 1, 2, 3, 4, 5. Are you okay, Mary Frances? It's okay. I can come help. 1 through 5 in your first list. Yes. 1, enter. 2, enter. 3, enter. 4, enter. 5, enter. Okay. Go to the right to your second list.
2.
2, 4, 6, 8, 10. Yes. 2. Yes. We'll just go back.
So list 1 is our X's?
Yes.
The X's.
So list 1 is our X's. List 2 is our Y's. 2, 4, 6, 8, 10. That is correct.
1 a.m. 2000s music.
All right, is everybody there? You got it?
My acne.
List 1 and 2. Okay, we were graphing yesterday. Now we're wanting to plot. If we go plot and also have an equation in y equals, it's going to do both. So we don't want to see both. So go to y equals and make sure you don't have anything in y1, y2. So go clear those out. Okay, those are cleared?
Then do we go back to stat?
No?
No.
Then we are going to do second y equals. And your screen looks different. It's stat plot. It's statistical plot. Okay, we're going to do a stat plot. Is everybody with me? Okay. Toggle down and hit enter on the word on. We're going to turn it on.
Where?
Yeah.
Plot.
Plot 1. Yeah. Tab down to 1 and make sure your stat plot is on. Only the first one. Yes.
Wait, I can change the kind of like.
Then press enter on 1. So that it should have brought you to another screen.
What? Mine didn't. Mine just says plot. Yeah, mine just beeping blue.
Oh.
Mine beeping orange.
Hit enter one more time.
Clear. That's what mine is.
Okay, let me just see your calculator for a minute.
Yeah, mine's doing too. Mine's beeping.
Okay, look. Look, I'm going to quit. So I did second. I'm on 1. I hit enter. Stay there. All right, so you should be on this screen.
Yes.
Everybody on this screen? Yes, yes. Okay, you're on this screen. Yes, now we're going to tell it what kind of plot we want to see. And mine is the first one. It's dots graphed.
Do we want to change it or no?
No, that's what we want. We want the dots. But do y'all see the little box and whiskers?
Yes.
Yeah, we're eventually going to do the box and whiskers.
So we don't change anything on this page?
Let me see what yours looks like. No, you want it on the dots. Down, dots. Okay. And it tells you your X value, your X list is list 1. Is that true?
Yes.
And your Y list is list 2.
Yes.
And it shows you what kind of mark. You can change the kind of mark.
Yes. The color.
You can change, y'all can change the color. Mine is just going to be black and white.
Ooh, magenta.
Okay, are you ready?
Should we press light blue? Do we press it?
Now hit graph.
Graph?
Okay.
Wait, why is my graph? I need to change it to yellow.
Just enter. Just graph. No. Yeah. No, wait, you have to turn it on. Hit enter.
Wait, brown's not on.
Okay, now graph.
Wait, why is there?
There we go.
Gray.
All right.
Gray. What the heck?
Do y'all see it's a line? Y'all see it's a line? It's clearly linear. All right, so every arithmetic sequence is linear. All of them. all of them can be written in slope-intercept form if we have the explicit form. Note the difference. Everybody look. I want y'all to note the difference because you're going to hear this a bunch. I'm big on repetition, okay? For the recursive, all we need to know is the previous one and the difference. That's all we need to know. However, for the explicit form, we have to know the first term and we have to know the difference. Now, we may not know the first term, but we might have, as long as I have two terms, I can figure out what the first term is. We will work backwards, all right? But always with an arithmetic sequence, you're always adding the same amount every time, or subtracting. My numbers might be getting smaller. It might be 10, 8, 6, 4, 2, 0, negative 2, negative 4, right? We can be subtracting. So look at number 2 on page 12. And I want us to think, is this an arithmetic sequence, number 1? And if it is, what is the common difference? And the common difference is represented by the letter D in equations. All right. So, number 2, is it arithmetic?
Yes.
What's the common difference? Negative 20. All right. Number 3.
Negative 20.
Oh yeah.
Number 2. You were looking at number 3, I'm sure.
20.
Now, number 3, is it arithmetic?
Yes.
And the common difference is
Negative 30.
-30. Number 4, is it arithmetic?
Yes. Negative 10.
And -10 is our difference. Number 5.
Yes.
And the common difference is -2. 6,
4. Yeah.
and the common difference is,
Plus 5.
okay. So look at 7. Notice they use a sub n. What format, it tells you, but don't read it. Number 7, does that look like the recursive or the explicit form?
Oh gosh.
It looks like the explicit. Why? Because it looks like y equals mx plus b. So your explicit form will always look like y equals mx plus b. So could we find the 34th term? Yes, because we had the explicit. If I had the recursive, could I? No, because I would have to have the common difference and the previous term. But with the explicit, I can solve for any future term or previous term. All right, so I'm going to use U instead of A. And it wants me to find U sub 34. All right, let's just look at this. I should have tied something together, and let's actually go back. No, we're gonna write the explicit form when we get to number 11. Okay, so I'm not gonna make that point yet. All right, so all I have to do is do -11 plus 7 times 34. And then I get the 34th term. What is it? Somebody tell me. I don't like the way they wrote that. I would have
Wait,
written
wouldn't
it.
be 33?
Well, it just has n. Just like when I simplified, I said u sub n is 2n
227.
before.
If the thing was too.
Okay, we're going to come back to that. Actually, we'll go to that right now. So what is that?
227.
Did anybody else get 227?
I got 20.
227?
Yep.
Okay, let's jump to number 11, and then we'll come back. All right, it tells me, what does this mean?
The first sequence is 28.
The first term in the sequence is 28. And the common difference is 10. All right? It's given, number 11. I wrote what they had. Okay, let's write the explicit form. Because this is what I need to write the explicit form. All right, so any term is equal to the first term plus the difference. Well, I don't want to write difference. I actually want to write it. 10 times n minus 1.
Why is it n minus 1?
Because that's the explicit, well, we talked about it here. All right? Now, we're going to distribute the 10. So u sub n is 28 plus 10n minus 10. Now I'm going to combine the 28 and 10 so that u sub n is 10n plus 18. Okay, I really want to draw your attention to this. All right, this is in the format of y equals mx plus b. It's logical. If I'm graphing this, the first term is 28. If I'm adding 10, okay, I really want every one of your brain cells here. If I'm adding 10 each time, then to go back on the graph, what do I have to do?
Minus 2.
So, at 17, it's at 0. That's the y-intercept. Wait, it's 18.
I was like, what?
I'm sorry, I can't subtract, and we're pre-calculus. 28 minus 10 is 18. That's the y-intercept. Now look.
The y-intercept. No way.
Okay, now, if I were to calculate the slope of this line, it's the change in y over the change in x, right? I could use those 2 points. Y goes from 18 to 28, and it goes from 0 to 1. Right? So that is negative 10 over negative 1, which is 10.
The difference.
The difference is always your slope. The difference is always the slope of your line. So, this difference here always represents slope. And u sub 0 is your y-intercept. Got it? Make sense? Okay, so now going to number 8, what is my common difference for number 8? Negative 100, because that's the slope of that line. Does everybody see that? It's a negative 110n.
Wait, you're on 12.
Number 8.
Oh.
Number 8. Look at number 8. What is the slope? The slope is, what's the slope for number 9? What's the common difference for number 9? Negative 2.1. Do you see that?
Oh, yeah.
Well, what is negative 7.1? The y-intercept, which is u sub 0.
Wait, why is it sub-0?
Because,
Because, I don't know.
say it,
No, like, I can't explain it. I just,
okay? Because that's your x value, that's your y value. So to go back to 0 gives me my y-intercept. When x is 0, we have our y-intercept.
But like I thought the formula, that number has to be u sub 1.
That's before we distribute and simplify. When we distribute and simplify, okay, that's here. It was 28 before we distributed and simplified.
So when it is simplified,
When it is in its simplified form, looks like y equals mx plus b. So everybody look at number, let's 8. I feel like that would be easier. What's the y-intercept? I just want you to give me the y-intercept. 65, so that's u sub 0. What's the common difference? Negative 100. So what would u sub 1 be? No, we're starting at 65. What are we doing to 65?
minus.
We're
add-
subtracting 100. That's our difference. So negative 35. And u sub 2 would be negative 135, right? I'm right on board. I'm going to do some erasing. All right, here's what we said for number 8, right? We said the y-intercept was 65, and the difference was negative 100. Right? So that u sub 0 is 65. To get to u sub 1, I subtract 100. U sub 1 is 65 minus 100, which is negative 35. U sub 2, I'm subtracting another 100. Negative 135. U sub 3, I'm subtracting another 100. Negative 235.
So we're doing negative 35 minus 100.
Yes, the previous one minus 100. The previous one minus
Because you're just
100.
going down the thing like.
Correct. Yes. Makes
and
sense?
You know, and you would, the difference, you're going down because it's negative?
Because the common difference is negative 100 and not positive. Yes.
Okay.
Okay.
I can get that.
Not like you're going to have a test on this tomorrow. It's like you're going to have a test on this in a month.
Right. Oh, yeah.
Or
Yay.
6 weeks maybe.
Oh,
Wait, we got this. We got this.
Yeah, so this is an intro.
So is this like the first lesson?
This is the first chapter.
Chapter, that's right.
Yeah.
Ooh,
Oh.
guys, we're so ahead.
How many chapters are there?
14.
She's like,
That's kind of a lot.
It's a lot. Okay, I'm going to erase.
All of this is the first chapter.
Well, you know,
Somewhat. Give or
somewhat.
take.
wait,
It's
chapter
a
or
lesson in chapter 1. Okay. So that's arithmetic. All right?
Oh, there's another one to learn.
There's another one.
Geometry.
Then we'll sort of put them together. Geometric, yes. All right. Geometric, same kind of deal. We have our output and we have our input. So that, I'm going to erase this as well. All right, this is geometric. So that we have u sub 1, u sub 2, u sub 3, Paula, u sub 4. But instead of adding, we're now multiplying. All right, so if I start with 2 and I want my rate by which I'm multiplying by to be 2, now we have an R value, then I'm multiplying by 2. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Let's go to u sub 5. 16 times 2 is 32. So we are increasing exponentially. This is not linear. Our exponential
Zigzag?
graph looks like this. It grows really fast.
So it's a curve.
It's a curve. All right, so let's go back and put these numbers in our stat list. So go back to stat. Wait, your calculator has to be on first. Go back to stat, edit. I'm not going to change list 1 because list 1 is still my X values, and I'm going to leave it 1 through 5. Now, you can write over list 2. You don't have to go clear it. You can write over it because we're going to put the same number of values in it. So this time you're going to put 2, 4, 8, 16, 32. So 2, enter. 4, enter. 8, 16, 32.
Yeah, big graph.
And then, yeah, we've already got our plot turned on, so you can just go straight to graph.
Wait, why does my
Now, do we see all of them?
No.
Why? Because does our window include Y as 32? So go change your window.
What part of ours should change?
Okay, everybody look. Our X values, everybody listen. We're going to be logical, okay? Our X values are 1 to 5. So you want to make sure your X values, your range goes from 0 to 6 because we want to see 1 and 5. Our Y values go from 2 to 32. So you want to make sure you see all of those. So your Y min could be 0, your Y max could be 35.
So we should wait.
Well, I see them.
What are you trying to base this on?
Our window.
Min, what's the number? 2?
All right. No, because then it's going to be right on the edge. Go below it. I went 0 to 35. For my Y min, 0. My Y max, 35.
And then
For my X min, I went from 0 to 10. Okay, so y'all need to be thinking, what do I need to see on my window? I need to see all of these numbers. So my Y values, I need to see 2 to 32, so I want to go smaller and bigger. My X values, I want to see 1 to 5, so I need to go smaller and bigger. Make sense? All right, this is what the geometric sequence looks like. Now, the way I can find my ratio is this. I can take all right, y'all look. I can take 2 times the ratio equals 4. And divide by 2 to get my ratio of 2. Okay, that was easy, right? It's not always that easy. So I could take u sub 2 divided by u sub 1 gives me my ratio. Any 2 sequential values. I could take u sub 5 over u sub 4 to get my ratio. To get my common difference, I would take u sub 2 minus u sub 1 as my difference. Or I could take u sub 5 minus u sub 4 to get my difference. Make sense? So once I have my ratio, which is 2, my ratio is 2, then I can write the recursive form. U sub n is the previous one times the ratio. Right? So to get to number 6, I could say u sub 5, u sub 6 rather, u sub 6 equals u sub 6 minus 1 times the ratio. Or it would be u sub 6 equals u sub 5 times the ratio. Well, I have u sub 5 and I have my ratio, which is 2. So to get to u sub 6, I just take 32 times
2.
2. That's correct. It'd be 64.
And so, like the u sub 6, you just gave that as an example, but they'll ask us to find it.
Yes.
So you just do that.
Yes.
What is this formula called?
The recursive. It is recursive geometric.
Will you give us like the whole sequence, or will it say like
Not
starting?
always. Not always. Okay. Well, let's just decide on page 13 if these sequences are geometric, and if they are, what is the common ratio? All right. Look at number 1. Is it geometric?
Yes.
All right. Then what is the common ratio?
-6.
We're multiplying by -6 every time. Because -1 times -6 is 6. 6 times -6 is -36. So the signs alternate. All right, number 2. Is number 2 geometric? It is not. Is it arithmetic? It is not. It is neither. All right, number 3. Is number 3 geometric?
No.
Because, okay. So how do we get from 4 to 16?
Times 4.
Times 4. Then 16 times 4, is that 36?
Nope.
It is not. What about number 4? Is number 4 geometric?
Yes.
Yes, it is. We're multiplying by 5 each time. Make sense?
Oh. Yeah.
Number 5, is it geometric? Yes. Number 6, is it geometric? What's the ratio? -5. All right, now, how do we get the explicit form of geometric? All right, let's just think. We know the ratio is 2. Let's just look at how we got u sub 4 from u sub 1. Okay, how many times do we have to multiply 1 by to get to u sub 4? So we have 16 equals 2 times the ratio. How many times do we have to multiply the ratio? 1, 2, 3. So it's times the ratio cubed. Three is 1 less than 4, right? 3 is 1 less than 4. Just like we did 1 less difference added. Like if in the difference, if I wanted u sub 20, I'm multiplying the difference by 19. Here, my ratio will be raised to 1 less value than the sub number. Got it? So if I want u sub 20, I'm going to take the first term and multiply the ratio raised to what? 19. Got it? 1 less. Got it? So I could find any number by taking the first number and raising it to the ratio, multiplied by the ratio times n minus 1. 1 less. Okay, so let's just do that and do u sub 6. So what is u sub 6 going to be? You know, yes?
If it's the number minus 1, and if you're trying to find the first ones, then the number must be 0. But you know,
Correct. That is correct.
so the first one is 1.
In most cases, the first term in the sequence, okay, everybody listen, we're going to get to this. But in most cases, you start with u sub 1. Unless we're talking like a physics or a business problem. Like I'm throwing a ball up. So we're going to get to that. It's all geometric sequences on how balls move.
So
Most of them will be 1. I will tell you when it's going to be 0. Or if you start a job, the first day, the day before you start the job, how much money do you make? 0. Okay, so
0.
that's going to be like when we're going to use that. All right. All right. All right. So what is u sub 6 going to be? You already know it's going to be 64. All right. We're going to use the explicit form and the first term with the ratio to find the 6th term. Got it? So we want to know the 6th term. We're going to take the first term, multiply it by the ratio to the 5th. 6 minus 1.
Yeah.
Got it? Okay. So u sub 6 equals the first term times the ratio to the 5th power, and you should get 64. So we can actually solve for the 20th term. We could take the first term times the ratio to the 19th power. What is that? You can do that in your calculator. Do you ever know how to do that in your calculators?
I think you told us.
Okay, let's see if you can do
Figure
it.
it out, but why?
Let's see if you can do it.
I love that it has the whole alphabet. History.
Is that what you got? 1,048,000.
How do you do it?
Okay, you here's what you do. You do 2. I raised it to the 20th power because multiplication and exponents is addition.
Wait. Oh, so just 2.
So I just did 2. So when your first one term is the same as your ratio.
How do you raise it again?
Okay, look, it's this carrot top right here.
Oh.
Carrot top,
What carrot?
20.
It's just an upward arrow. I don't know why they're saying carrot.
Okay, that's just what they say. All right.
So if you're like first number,
I was like, why is Caitlin keep saying carrot?
Yeah,
Ratio.
so
you're
Carrots.
saying you just raised it to whatever.
That's rarely going to be the case.
Kiss me on the. Wait, I'm gonna write all the words to say we're so
All right, let's look at use of 4. Use of 4. Let's look at the fourth one on this sheet on page 13. All right, what did we say for number 4 was the ratio? The ratio is 5, and u sub 1 is -3, right? Could we write the explicit form? Yes, we can. U sub n equals u sub 1 times the ratio to n minus 1. So u sub n equals u sub 1 -3 times the ratio 5 raised to n minus 1. That would be the explicit form. So I could solve for, this is going to be a big number, maybe. Let's just go to u sub 6. So it's going to be -3, that's negative, not minus, times 5 to the 5th power. Let's see if y'all can do that. It's going to be a big negative number.
$375.
Yes, got it?
Hey guys, I wasn't there yet.
Okay, let's look at number 7. We're just going to find the first 5 terms of number 7. Okay, you ready? Number 7 on page 13. Got it? All right. What's the first term? Okay, I'm going to write on the board.
First one would be 1. Oh, times 1.
Let me see how well this erases. No. All right, so it would be u sub 1 equals 3 to the 1 minus 1, which is 0, so it equals 1. This would be 3 to 0. Because
you would be.
anything to the 0 power is
No, I mean like how do you know it's u sub 1?
what's said to find the first 5
And you're
terms.
multiplying.
So 1, 2, 3, 4, 5. U
I
sub
didn't see
1, U sub 2, U sub 3, U sub 4, U sub 5. We're finding the first 5 terms. Make sense?
Yeah.
All right, so U sub 2 is going to equal what? 3 raised to the
Second power.
2 minus 1.
Oh, or 3.
I'm following. N. N is here. So it's just
3.
3. Our U sub 3 is going to equal what? 3 raised to the
Second.
3 minus 1, which is 2, and that is 9. 4 is
3 to the 4 minus 1.
3 to the 4 minus 1, which is
27.
27. U sub 5 is 3 raised to the
30.
5 minus 1, which is not 30. It's 27 times 3.
It's okay.
81.
It's okay, baby.
Does that make sense? Makes sense.
I can fly.
So do you know the common ratio? You know the common ratio? It's 3. Yes.
Yeah.
Okay. Is everybody looking? What time is it?
It is
1:26.
26.
We have until 2.
We have 30
Minutes.
We have 24
Okay.
minutes.
All right. Let's move to page 14. Let's move to page 14.
Oh, it's 26? Okay, I thought it was 26.
Yeah.
Wait.
We have until 2,
I thought it was 136. Sorry.
isn't it?
It's 126.
Oh yeah, I have like over 30 minutes. Okay.
Yeah.
All right. On 1 through 4. Yes.
Could you go back over 8?
This.
Or which page?
Eight.
That's right. Okay. Let's see, Christopher.
Let's just do on that one. So we're going back to page 13. We'll do like use of 3.
Oh, it's old maybe.
All right. So use of 3 for number 8, back on page 13. I went back one. Would be 2 times 1/4 raised to the 3 minus 1, which is squared. That equals 2 times 1/4 squared. Okay, this goes to the rules of exponents. 1/4 squared equals 1 squared over 4 squared.
Oh, just kidding.
And how do you know it's 3 minus 1? Oh, it says that?
Yeah.
Where? Number 8?
No. I just chose to solve for. I just picked 3.
Okay.
I just picked 3.
It's 1/8. The whole problem.
4 squared, right. So 2 times, that would be 2 times,
1/16.
yeah. That's 2 times 1/16, which is 1/8. Make sense? Got it?
Yes. I like this.
Okay. All right, I'm gonna erase this. Now let's go on to page 14. I don't know why all markers are not created equal, but they're not.
Oh. Wait, okay.
Some markers are so much easier to erase than others. But if I brought these home, my board wouldn't have an issue. I don't know why my board at home doesn't have an issue.
Don't act like you can't hear us.
Oh, I can.
Okay. I'm gonna be using paper towels all year. I guess. I just bought 2 new markers. And they're magnetic. And erase some, but I just thought I'd be able to do this. But,
Is it the purple thing? My
okay.
mom uses it. So she uses it for the ball. Okay.
I use it for.
Okay. Let's look at page 13. No, 14. Sorry. Right? 14. Look at page 14. Everybody with me on page 14? We're going to decide, are these arithmetic or geometric? All right?
Okay.
So number 1, or neither. They might be neither. Number 1, arithmetic, geometric, neither. What are we multiplying by?
No.
5.
Yes.
Okay, so I want to pause for a minute and show y'all something. How can I make sure the ratio is the same? I'm asking myself, do I show this to y'all? I'm going to show it to you the first week. Okay, so I could do 15 divided by 3, that is 5. But could I do somehow, so that's, wait, it's not done yet. I'm not finished writing. But how many times have I multiplied 3 by 5 to get to 1875? 4, right?
Is it U4?
Okay, wait. That is U5, right? But I multiplied it by 4 so I can take the fourth root of this. So do 1875 divided by 3. And then take the fourth root, which is in math. And do you get 5?
Which is in math.
The fourth root is in math. It's, yeah. Do you get 5?
Yes.
Hold on.
You get 5?
Yep.
Okay. So I could find any ratio. What did I do? I took, okay, if I look, I took 5 minus 1 u sub 5 over u sub 1. I wrote that 5.
I'm gonna go.
Got it?
Yep.
So I could take the ratio is n minus 1 of u sub n over u sub 1.
Oh yeah.
It's the same thing I did here and here. Okay. Number 2. Is this one arithmetic, geometric, or neither?
I can't see what. I only had 2 pieces. It's okay. No, I only had 2 pieces.
Is it geometric?
No, guys.
It could be multiplying by a negative fraction, and so it could be getting smaller.
Negative 2.
Let's make some.
Oh, yeah.
No. Guys, my mom has come in her office. Just wait. No, just wait 30 minutes.
Okay, I need y'all to verify, is it or is it not?
Which one?
Number 2.
Number 2.
Yes.
Times negative 3. Well, it would be negative 1/3.
It's geometric.
Yeah. Negative 1. Wait.
Yes, it is.
Wait, can't you just see? Can't you just know by looking at it? Like if you say like 5 times what is this, then this.
What's the ratio?
You.
Fourth dimension.
No, it's not.
Times negative 3.
It is. What?
Why is it 1/3?
Because
Well, I did the ratios. We're going backwards. I did the ratios.
Did it for a second.
And point 3 repeat.
I just wrote God.
So I'm multiplying by negative 1/3 each time. Okay. What about number 3? It's times what? Number 3? Multiplying by 2, so it is geometric. What about 4? What's the ratio? Say it, Hannah. 1/2. That is correct. Okay, for number 5, what's the common difference? Negative 30.
Oh yeah.
Got it?
This doesn't make me wonder.
All right, number 7, what's the common difference? Negative 6. Number 9, we're just going to go to the left-hand column. Number 9, what is the common ratio?
Negative 5.
5. Got it?
Yes.
Number 11, what's the common ratio?
3.
3. Okay, could we find the recursive formula for number 13? Okay, first we have to decide, Is it arithmetic or is it geometric? So, number 13, arithmetic or geometric? Okay, it's arithmetic, so there's a common difference. What's the common difference? Negative 100. Got it? So, the recursive form is u sub n equals u sub n minus 1 minus 100. That's all you have to write. Because the recursive form says any term equals the previous term plus the difference. Got it? Okay. What is number 15? Is it arithmetic?
Geometric.
It's geometric. So we don't have a difference. We have a ratio. What's the ratio?
-5.
We're multiplying by -5. So now this was arithmetic recursive. This is geometric recursive. Geometric recursive says we can find any term by using the previous term and multiplying it by the ratio. So the recursive form would be, just plug in the ratio. Okay, let's use these same two and do the explicit. We're not going to go down, all right? With the recursive, we just leave u sub n and u sub n minus 1. With the, all we needed to know was the difference. If I'm solving for one, I need to know this previous term. If I'm solving for the next one, I need to know the previous term. With the explicit, always, I have to know the first one. And I have to either know the difference or the ratio. All right? So, this is number 13, right? This is number 13. So, the explicit for the arithmetic is u sub n equals u sub 1 plus the difference times n minus 1. I have to know u sub 1, and u sub 1 for number 13 is negative 15. Right? Yes. And we said the difference was negative 100. So it's going to be minus 100 times n minus 1. I just substituted u sub 1 in. I substituted the difference in. Now I'm going to simplify. So we'll distribute the negative 100. That u sub n is negative 15 minus 100n plus 100. What's 100 minus 15? So it's negative 100n plus 85.
Oh,
100 minus 15? 85? That's the explicit form.
And then
That's it.
it looks like the
Fine. Looks like y equals mx plus b. I was expecting my slope to be my difference.
so would
In the
that
arithmetic.
be the answer?
This is it, right here.
Cool.
If it's just asking for the explicit form.
She's so mysterious.
All right, if I'm asking on a geometric, then it's u sub n equals u sub 1. We're multiplying times the ratio n
N
minus
minus
1.
1.
Okay? I know that the ratio is negative 5. And the first term was 3. Okay, so u sub n equals the first term. I'm just substituting these numbers in. 3 times the ratio, which was
five
negative 5
oh,
times n minus 1.
So, that's the answer. But we
Okay.
didn't ask us to.
I have a question. All right, so let's tie this into last year, previous year. Previous year. All right, everybody look at this. When do we subtract exponents?
When they're divided.
When they're divided. Could I write this?
Yes.
I can do that? Okay. So could I write this as could I write this as all right, so that's going backwards, right? With the rules of exponents. Because you have to know division and subtraction. So really it goes to, so we can simplify it. This is the way your textbook is going to simplify it and
And
ask for the
Do
equation.
you want us to do it like that?
I want you to be, yes. That's probably the hardest types of problems. Okay. Let's look at some trig before we leave, because we're going to spend the last part of this semester, the first semester, on trig, and the first part of next semester on trig. So it's about a third of the year will be spent on trig. So y'all remember SOHCAHTOA.
Of course we do.
Okay. What does that
Tattooed
mean?
inside my brain.
What does that mean? What's
Sine-
so?
Sine, opposite hypotenuse, cosine, adjacent hypotenuse.
Yes, keep going.
Tangent is adjacent. Wait. TOA, opposite opposite adjacent.
Yes. All right. And does anybody remember the other ones we did last year? I'm gonna have to buy all colored markers, huh? So the sine of an angle equals opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse, and the tangent of an angle is opposite over adjacent. Okay, this one was easy. I'm writing cosine. Cotan. The cotan of an angle equals adjacent over opposite. Or it's 1 over the tan. It's the inverse. Okay? Do you remember what was the inverse of the sine? The third letter was an S, so it's the cosecant. Cosecant. It's spelled cosecant, which is CSC, and it's 1 over the sine of theta, or hypotenuse over opposite. The secant, which we have to look at the third letter, SEC, is 1 over the cosine theta, or hypotenuse over adjacent. These ratios for the sine and the cosine. This, I need y'all to clearly know this. This is the ratio. this is the angle, which we're gonna look as radians. We're gonna go to radians. So quick. It's just another way to measure an angle. Angles measure the rotation of a ray. It actually starts at the positive x-axis and rotates around. And it measures the angle at which it rotates. Radians measures the circumference of the rotation. Not the angle, but the circumference if we had a radius of 1. Measures the circumference. So it's like 2 pi r, circumference. So that's why in radians we have pi, because it's the circumference, 2 pi r. All right? The ratio of the sine and the cosine, the smallest ratio will equal -1. The largest ratio will be 1. We'll never have a ratio less than -1 or greater than 1. Never, ever, ever. So go to page 20. It is the unit circle. It is what we will have to
Wait, that's
memorize.
what's on my book.
Yeah,
There's a sticker.
there it is. You're right there. Unit circle.
Sticker of it.
All right, so let's just work on this for the last few minutes because it will be so important for y'all to know this. All right, look at the angles. If you start on the positive x-axis, that's 0 degrees. It's also 0 radians. All right, and then it goes to a 30-degree angle, then a 45-degree angle, then a 60-degree angle, then a 90-degree angle. Even if I went down, okay, all the way around is how many degrees?
360.
360. So if I go down this way, it's 360 minus 30, which is,
330.
and then if I go one more, it's 360 minus 45. And if I go one more, it's 360 minus 60. And if I go to the y-axis, it's 360 minus 90. 270. Do y'all see that? All right. Now, let's just look at the 30-degree angle. Let's say that's 30 degrees. We have a radius of 1. Could we figure out what the circumference of that is? Yes, it's a sector. And the way you calculate a sector is the central angle over all the way around times 2 pi r. 2 pi r. I can simplify that to what? That's 1/12. 1/12 times 2 pi. 1/12. I wrote 2. 1/12. So that equals what? 2 pi over 12, which is pi over 6. Look at the radians related to 30 degrees.
Oh.
It's pi over 6. Got it? So the first rotation, I need to be on the correct side. No. The first rotation is the 30 degrees. No, let's see. It's on this side. 30 degrees, but it's pi over 6. So 30 is pi over 6. If I go 45, it's pi over 4. That's easy to remember, both 4s. 30 pi over 6, 45 pi over 4, 60 is pi over 3. So the 60 and the 30 swap. Do you see that? 30 degrees, pi over 6. 45 degrees, pi over 4. 60 degrees, pi over 3. And this is what part of the pi? Pi over 2. right? Because this, a straight line, is a whole pi. So we go 0, pi over 2, a half a pi. Pi, are y'all following me? 3 pi over 2, because it's another half. All the way around to 2 pi. The whole way around is 2 pi. Why is the whole way around 2 pi? Because all the way around is 360 degrees over 360 degrees times 2 pi, the radius, which is 2 pi. Got it?
That's so cool.
Okay, so we're going to memorize quadrant 1 and then apply it to every other quadrant. Because in the quadrants, all students take calculus. That's right. In the first quadrant, all of our ratios are positive. And your ratios, the first ratio is the cosine. You see 1 at 0 degrees in parentheses.
Yes.
That's the cosine. The second number 0 is the sine. If you put in your calculator the cosine of 0 degrees, do that. Cosine 0 equals, what do you get? 1. That's correct. 1. Got it? So those are not coordinate points. Although cosine does go with x, sine y. Remember we did that in algebra? Cosine x, sine y. Cosine x, sine y. Cosine x, sine y. We said that a lot. That's because we're going to get to here. Okay? All right. So the 1, 0 represent cosine, sine, but it's also the coordinate point on the graph. All right. Then we move to 30 degrees. All right, so if it's cosine, sine, look at that first quadrant. There are only a few measures, a few ratios. There's, what are they? Square root of 3 over 2. There's square root of 2 over 2, and there's 1/2. You got it? 3 ratios in that entire first quadrant. You see that? All right, the first one is the cosine. So the cosine starts at 1. Then it goes to what? Square root of 3 over 2. Then it goes to square root of 2 over 2. Then it goes to 1/2. So listen, it goes from 1, 3, 2, 1, 0. Look at the 90 degrees. Cosine counts down. It goes from 1, 3, 2, 1, 0. Say that with me. It goes from 1, 3, 2, 1, 0. Okay? But the 3 and the 2 are under the square root. So it goes from 1, square root of 3 over 2, square root of 2 over 2, 1/2 to 0. And that is 0, pi over 6, pi over 4, pi over 3, pi over 2. The sine just goes the other way. The cosine counts down, the sine counts up from 0, 1, 2, 3, 1. The cosine counts down from 1, 3, 2, 1, 0, where the sine counts up from 0, 1, 2, 3, 1. Got it? So the sine of 0 degrees is 0. The sine of pi over 6 is 1/2. Pi over 4, square root of 2 over 2. Okay, the cosine and the sine are the exact same on pi over 4. Look at that. They're the exact same in quadrant 1. Pi over 3 is square root of 3 over 2, and pi over 2 is 1. Got it? All right. The sine counts up or down? Up, cosine down. Sine counts up, cosine down. Sine counts cosine down. From 1, 3, 2, 1, 0, or 0, 1, 2, 3, 1. Got it? So if we can memorize that, that's going to be amazing.